Hey guys, what's up? How are you today? Well, welcome to Nick the Geek, and this is another week and another chapter that we're gonna talk a little bit about the derivative as a limit. This one is gonna be a little bit more complicated than the previous videos, but I will give it a try and I will do my best to give you the easiest path to go through this definition. So welcome guys, and this is Nick the Geek. Okay, first of all, the first thing that we have to remember is the definition of this factor case, where we have a plus b squared is going to be a squared plus the multiplication 2 times a times b plus b squared. That's the first thing we have to remember. And then the second thing we have to not remember, because this one we didn't know about this one. F apostrophe is going to be the derivative of the function. So if we have f x as a function of x, then f with this apostrophe is going to be the derivative of that function. And as a definition, we're going to call that as a limit when h wants to go to 0 of this ratio that we have there. We're gonna make an example, so in that way that's gonna look a little bit easier for you to understand and to remember. So, well, just keep in mind these two things and this definition, and we go from there. So one important thing to keep in mind is let's go back to last week where we met this definition. Remember that we were talking about this. If we have a function which is x squared, then the derivative will be 2x, and that's because this formula, if we have a function, a power function, then the derivative will be written like that. Well, we're gonna make an example about how to get this from the definition of limit and from the notion of limit. Okay, as a first step, we have this function x squared, and we're gonna write the definition of derivative from the limit, which was the first formulas that we talked about. So we're gonna apply this formula to the function we have, and that's gonna give us this. If you have any question, just feel free to comment and to ask, because this is very important. So if we have a function which is x squared, then the function not of x but of x plus h would be the same x plus h but square, because that's the function, right? Then we're gonna take away the original function, which is x squared, which is right here, and that is something that we're gonna divide into h. After that, if we go to the factoring case that we were talking about at the very beginning, we're gonna just expand this x plus h squared, and we're gonna turn it like this. Did you remember the definition? Well, here in this case, we're gonna be a very, very interesting thing, which is the fact that this x squared is taking away this x squared, so we can just eliminate these two variables because one is taking away the other, so that's 0, right? Then we're gonna proceed to rewrite what's left here. So this is nothing different than this same expression, but just written in a clear way, because now we don't have this x squared and we don't have this minus x squared. The next step is that we can notice that here we have h, here we have h, so we can factor at least one h in order to get an easy division from this h with this h, right? That's what we're gonna do here. So we're gonna factor one h, and we're gonna factor it times 2x plus the other h, and we're gonna divide that into the initial h. So now we know that we can just eliminate this h with this h from the lower part, and we can turn it into this new expression, which is just what we have in the parentheses here. So what we're gonna do is we're gonna apply the definition of limit here, and we're gonna expand this limit into a sum of limits. So that's a property that the limits have. The limit of a sum is the sum of the limits. That is something that we're gonna go deeper in another chapter, but here I just wanted to give you a first glimpse of what it is. So then, what we have to know is that if h tends to 0, then all this goes to 0, all this part, because it's the limit when h approaches to 0 of h. So that's 0, just for definition, because h is approaching to 0, right? So we have here is the limit of h approaching to 0 of 2x, which is going to be 2x, because x is not depending on the h from the limit. So we can get rid of the limit now, because x is not depending on this h anymore. So we're good. So now we just demonstrated that the derivative of x squared is 2x, according to the definition of the derivative. So we're good to go. And now we're just gonna use another example. If we have a function which is a number, then according to the definition, we remember that the derivative of a constant is 0. And that happens because in this case, this function, 7, is not depending on x. So if it's not depending on x, then it's not depending on h neither. So that's why fx is 7, and the function of x plus h would be 7 as well. So 7 minus 7 is 0, and that's why the derivative of a constant will be 0. And as a last example, we're gonna use the definition to demonstrate that the derivative of x is 1, and we're going to show that in this example. So according to the definition of limit of the derivative, we can just go ahead, and if the function of x is is x, then the function of x plus h is x plus h, and we're going to take away the original function, which is x. So that's x plus h minus x, and we're going to divide that into h. So now we can just go ahead and take these two x's from our spots, and now we have this one, which is exactly the same as this one, just reorganized and without the x. So we know that any number divided into the same number is 1, right? So the limit of h approaching to 0 of h divided into h is the same thing as that limit, but of 1. And the limit of a constant is that constant itself. And that's another thing that we're gonna use for our limits lesson that will be coming soon. Well, that's it for now, guys. I really hope you have enjoyed this lesson, and just don't forget to subscribe. And if you have any questions, just feel free to ask, and I'll be so happy to answer all your questions. Well, guys, take care, and thank you very much for joining this week's chapter of Nick the Geek.